Hi everyone, my name is Ashka and I'm a software engineer at VMware with the Greenplum Unmanaged Data team. Today I'll be discussing multi-byte delimiter support with Greenplum PXF, specifically working with CSV files. So first, what is PXF? PXF is Greenplum's platform extension framework. It provides parallel high-throughput data access and federated queries across heterogeneous data sources. It supports a variety of different file storage systems, including database management systems, Hadoop distributed file systems, network attached storage, cloud storage, and object storage. Supported file types include CSV, Parquet, ORC, Avro, and JSON. So, as the gateway between Greenplum database and external systems, PXF allows users to read and write files to these external systems. And in this process, if the files being read are CSV files, PXF leverages the server's copy framework to stream this data into Greenplum. And this can be problematic, as files created by external systems may not adhere to some of the limitations that Greenplum has. So for example, a CSV file that uses the currency symbol as a delimiter cannot be read by the Greenplum copy framework. And this shortcoming stunts PXF's ability to load in such a data file. So what exactly is the Greenplum copy framework? The Greenplum copy framework takes in a data stream and then parses it based off the table definition options provided by the user. These options include delimiter, quote, and escape, which can only be single 1-byte character values, such as comma, pipe, or quote. The fourth option that we'll look at today is new line, and this can only be line feed, carriage return, or carriage return line feed. What is a multi-byte character? So a multi-byte character needs more than 1 byte to be encoded. For example, in UTF-8, the currency symbol is encoded as a 2-byte character, C2A4. Emojis are 4 bytes, and the Chinese character ting and other Chinese characters are encoded as 3 bytes. To add a layer of complexity, it's actually possible for a character to have different byte representations in different encodings. So for example, the currency symbol is encoded in Latin 1 with a single byte value, A4. So what if we want to read a file on an external system that contains a multi-byte delimiter into Greenplum via PXF? How do we do it? So the copy framework code comes from upstream Postgres, and there's no indication that upstream will be adding support for multi-byte delimiters anytime soon. There's concerns regarding overhead, introduction of bugs, and performance degradation along a code path that's relatively well used. So instead, what we can do is use a custom formatter. Custom formatters hook into the copy framework code and allows users to format incoming data as they see fit. So we can use this to parse the incoming data stream and handle multi-byte delimiters with PXF. As such, with PXF 670, we have introduced the PXF delimited import formatter. It's a custom formatter introduced that allows users to load and query CSV data files with multi-byte delimiters into Greenplum via PXF. So you can create an external table, set a custom format, and your formatter to PXF delimited import and provide the multi-byte delimiter of your choice. So how do you access this new feature? With PXF 670, we bumped the PXF extension version from 2.0 to 2.1. Existing users of PXF will need to run alter extension PXF update in order to get the new formatter. So let's see this in action. Here we have the database multi-byte demo, and it is encoded in UTF-8. So we have installed PXF version 2.0, which has the existing 2 formatters, PXF writable import and PXF writable export, as well as 3 functions that are needed for the PXF protocol. On the left, we have cities.csv. It is 10 rows of data that contains an ID, a city, and a country. So let's create a table. And we're going to create this table with format CSV. So we're going to use the server's copy framework. And you can see that we can successfully read in this data. Now, let's say that the data, we now have cities multi-byte, which is the same data, but the difference is instead of a comma, we're going to use the currency symbol. So if we try to create this table using format CSV, we actually fail because in UTF-8, the currency symbol is 2 bytes. So now we'll go and we'll update PXF. And we'll see here that we now have PXF version 2.1, and we have a new delimiter, PXF delimited import. If we try to create this table now, so we'll use a custom format with our PXF delimited import formatter and the currency symbol as our delimiter. And if we select from this table, we can successfully query this data. Now, imagine instead that the file is encoded in Latin 1. So here we have the file citiesencoded.csv, and it's encoded in ISO 88591, which is Latin 1. Now, if you were to look at the file itself, my local machine is in UTF-8, and any Latin 1 file that has the currency symbol in it cannot be properly read. So here you see it's the same data, but with an unknown character value for the delimiter. Now, let's create an encoded table here. So as the data file is in Latin 1, the table encoding here must be Latin 1. And so using that same, our custom formatter, as well as the delimiter value, we can query this data file, and we see the data as we expect. We can also choose to create this table using byte representation. So here you can see the formatter is PXF delimited import, and our delimiter value is actually written in the server database's encoding. So even though the file itself is in Latin 1 and our table encoding is in Latin 1, if you choose to write the delimiter in byte representation, it needs to be written in the server database's encoding. So we're encoded in UTF-8, and in UTF-8, the currency symbol is 2 bytes C2A4, and that's what we see here. And if we run a query select, we can see that we can successfully read the data. Cool. So what are the limitations and assumptions? As I mentioned in the demo, the delimiter character, if you choose to write it in byte representation, must be written in the server encoding. A couple other limitations that we have is that the quote character, if you choose to define it, must quote every column. We also currently do not support extraneous or trailing white spaces, so if quote is defined, then you cannot have spaces between the quote value and the delimiter value. You cannot have spaces between the delimiter value and the new line character, for example. And the last assumption that we make, or the last limitation that we have, is that new line characters must be consistent across the entire file. So for example, you cannot have some rows ending with new line or with character turn. You cannot have some rows ending with line feed. It needs to be consistent across the entire file. So the default value for new line is line feed. If you define the new line option, users must also define it in the location URI. So these are just some of the limitations and assumptions that we have here. I wanted to thank you all for listening, and I hope you guys enjoy the new feature. Thanks so much.